The central processing unit, CPU, is the brain of the computer. It is responsible for executing all of the instructions that make up a computer program. CPUs work by following a fetch-decode-execute cycle. In the fetch phase, the CPU retrieves the next instruction from memory. In the decode phase, the CPU determines what the instruction is and what data it needs to operate on. In the execute phase, the CPU performs the operations specified by the instruction and stores the result in memory. The CPU has a number of different components that help it to perform these tasks. The most important components are the control unit, the arithmetic logic unit, ALU, and the registers. The control unit is responsible for coordinating the operation of all of the other components of the CPU. It tells the ALU what operations to perform and when to perform them. It also tells the registers where to store data and when to retrieve it. The ALU is responsible for performing all of the arithmetic and logical operations that the CPU needs to perform. This includes operations such as addition, subtraction, multiplication, division, and comparison. The registers are small, high-speed memory locations that the CPU uses to store data that it is currently working on. This data could be instructions, data, or results of operations. The CPU also has a number of other components, such as the cache, the memory controller, and the bus controller. These components help the CPU to perform its tasks more efficiently. Here is a simplified example of how a CPU works. 1. The CPU fetches the next instruction from memory. 2. The CPU decodes the instruction and determines what data it needs to operate on. 3. The CPU retrieves the necessary data from memory. 4. The CPU performs the operation specified by the instruction. 5. The CPU stores the result of the operation in memory. 6. The CPU repeats steps 1-5 until it reaches the end of the program. CPUs have become increasingly complex and powerful over time. Modern CPUs can execute billions of instructions per second. This allows computers to perform tasks such as video editing, gaming, and scientific computing that were once impossible.